the Art of Worldbuilding podcast, episode number 11, part 1. Today's topic is how to create a planet. This includes talking about a world's rotation, the stars, asteroids and comets, and the impact of the sun and moon, including tidal locking, tides, the seasons, the hours in a day, and of course moonlight. This material and more is discussed in Chapter 2 of Creating Places, Volume 2 in the Art of Worldbuilding book series. Do you want practical advice on how to build better worlds faster and have more fun doing it? The Art of Worldbuilding book series, website, blog, and podcast will make your worlds beat the competition. This is your host, Randy Ellefson, and I have 30 years of worldbuilding advice, tips, and tricks to share. Follow along now at artofworldbuilding.com. In an earlier episode, I may have mentioned this idea that we talk about world building, but we don't normally invent the entire planet. However, that is the subject of this particular episode. When I say that we don't normally create the entire planet, I mean that we don't do so in extreme detail. We usually just pick a region or maybe one continent. So in this episode, when we talk about creating a planet, we're not talking about doing the entire thing in detail, meaning that every last civilization. We're talking about the actual planet itself. We may only develop one area of it extensively, but we still need the actual planet, of course. The focus of this episode is not just a planet, but one that is relatively similar to Earth, and the reason for this is that this is what most of us are probably going to invent. Even if we have unusual planets, our characters are probably coming from one that is more Earth-like. So what I'm not going to cover in this episode is any planet where the physics are dramatically different. This includes ideas like gravity being wildly different or the planet being tidally locked to its sun. These are certainly good ideas to explore, but one reason I'm going to not focus on those is that, for one, most of us do need an Earth-like setting, at least one of them, but there are so many variations that we could do, and some of them are found in nature, that I can't possibly cover them all. I'm also not a physicist or an astronomer. So if you're looking for information on oddball planets, unfortunately that's not what we're going to cover today. Such planets are probably more useful to those who are writing science fiction than fantasy, but there's no reason that we can't have fantasy characters who are hopping from one planet to another the same way that we do in science fiction. It's just that in sci-fi we use a ship, and in a fantasy setting we would probably use something like a magic portal. Worlds that are not Earth-like are good places for our characters to visit temporarily. And one reason we might want to do that is if there is something valuable on that planet. Any planet that is markedly different from Earth is probably going to have limited use to us as well. That might also be true of our characters. Regardless, we're going to focus on an Earth-like world, so here we go. The first thing we should talk about is rotation, because on a planet like Earth, the planet is spinning one direction or the other. It's either counterclockwise or clockwise. Which direction are we going? Counterclockwise, and this is why the sun rises in the east and sets in the west. If you want to do something different, you can decide that your planet is spinning the other direction and therefore these are reversed. This is a really quick way to pull your audience out of their comfort zone. This also means that other celestial bodies are also rotating in the opposite direction. Whether this has a practical impact on your world is debatable because for most of us we're probably not going to be talking much about this. On one hand, this seems like a big change, but it doesn't really change much about the details of the world. In other words, this alone is not going to make it stop being Earth-like. Now, there are some basic things that are affected, and we're going to talk a little bit more about this later. One of them is the ocean currents, and another one is which coast of a continent has warmer or colder air. Another issue is the way the prevailing winds will be reversed in each hemisphere. And if you're wondering what I'm talking about with all of those, we're going to dive a little bit more into that in a few minutes. The good news is that all of these impacts are simply a matter of reversing a direction that I'm going to talk about later. For example, if the planet is rotating one way and that causes warm water to be on one coast, and then you decide it's rotating the other way, you just have to decide it's on the opposite coast. I wanted to mention that now just in case I forget to mention it later when we're talking about some of those issues. It's just a matter of reversal. The next thing I want to talk about is the impact of the sun. You may have heard of this idea of a Goldilocks zone, and what that means is that our planet is not too close and not too far away from the sun for life to occur. Most of us are going to want to just leave this issue alone and not touch it. If you're entertaining the idea of having the sun be much larger in the sky, that could mean one of two things. Either the planet is much closer to it and not in the habitable zone, or the sun itself is much larger than our sun is. This issue of size could be a problem because it's entirely possible that this means the sun is putting out far more radiation, or that the solar wind from that sun is significantly stronger. And this is the kind of area that I don't want to get into too much because, again, I'm not an astronomer and I don't want to give you misinformation. But this is one of the reasons why we're focused on an Earth-like world. We could also decide to do a different kind of sun, such as a red dwarf. Such a sun has a smaller habitable zone and it's closer to the actual sun. This means, of course, that the planet is that close to the sun, and this has a side effect known as tidal locking. This has nothing to do with tides and oceans. What it means is that the same side of the planet is always facing the sun, and what that means is that one side is basically being blasted with sunlight all the time, and the other side is in perpetual darkness. Now, on one hand, this sounds kind of cool, but on the other hand, one side is not going to be habitable because it's too hot, and the other side is going to be too cold. So we're probably talking about a planet that is not Earth-like, and therefore it's not the subject of this episode. But I don't want to discourage you from exploring these options for planets that our characters visit temporarily. If you're looking for more world-building resources, artofworldbuilding.com has most of what you need. This includes more podcasts like this one, and free transcripts if you'd prefer to read an episode. You can also find more information on all 3 volumes of the Art of Worldbuilding series, which is available in ebook, print, and audiobook formats. Much of the content of those books is available on the website for free. You can also join the mailing list at artofworldbuilding.com/newsletter. This gets you free, reusable templates from each published volume in the series. You don't even need to buy the books to get these. I also send out contest information, free tips, and other stuff to help with your efforts. Please note that I do not share your email address with anyone because that's against my privacy policy, and you can unsubscribe at any time. Sign up today to get your free content and take your world building to the next level. The next thing I want to talk about is the impact of the moon, and this is a pretty big subject. It includes tidal locking, tides, the seasons, the hours in the day, and of course moonlight. Let's talk a little bit about our own moon and how it contrasts to other moons that we have found in our solar system. This is not a recommendation that your moon be the same, but this will give us a baseline for variations. Our moon has no atmosphere, but other moons in our solar system sometimes do have one, but it's very toxic. Our moon also has no volcanic activity, unlike many of the moons in our solar system. And these are not necessarily unrelated facts. You might also be aware that the planet Mars has no atmosphere. On the other hand, a planet like Venus does, and of course so do we. So one question is, why is this the case? And what I'm about to tell you is true whether we're talking about a planet or a moon. Basically, what scientists have said is that if there is internal activity going on within the planet, the kind of activity that results in volcanoes, this has a side effect of creating magnetism. This magnetism matters because it stretches out far from the body and turns into a kind of shield that protects the body from the solar wind that is coming off of the sun. If this magnetic shield is not there, then the sun's solar wind literally blows away the planet or the moon's atmosphere. It's been speculated that this is the reason why Mars no longer has an atmosphere. It's believed that it once did, and we've seen evidence of things like rivers on the surface. So then that begs the question, well, where did the water go, and what happened to the atmosphere? The last I heard, there is no longer any geologic activity on Mars, and as a result, the magnetic shield is gone, and as a result of that, the solar wind blew away its atmosphere, and now it's a dead planet. This may be what happened to our moon, but it doesn't really matter what happened to our moon. This is the basic idea. Part of what I'm telling you here is that if you would like to have a moon that has an atmosphere and forests and the whole bit, just like we have here on Earth, you can do this. And we'll talk a little bit more about this as we go along. Another issue regarding the moon is that our moon is relatively large compared to the planet that it is orbiting. Most of them that we've found in our solar system and even in other solar systems are significantly smaller. Why does this matter? Well, you should just understand the size of our moon, because if you decide to make one that's much bigger than ours, it's going to have a bigger impact on the planet. It is arguably more likely that in a fictional world and a fictional moon that it's actually going to be smaller than ours. However, by doing so, you are going to change its impact, and we're going to talk about what would happen if you did this. Another basic factor to consider about our moon is that it is in a relatively stable orbit. It is mostly circular, but a lot of moons out there are more elliptical. It's more like an oval. The basic issue that this is going to cause is that when the moon is closer to the planet, it's going to have more impact on it, and when it's farther away, it's going to have less. Again, most of us are going to want to go with something Earth-like and be done with it. Another basic fact to consider is that almost every body in a solar system is going to be rotating the same direction. This is caused by the gravity that caused everything to form in the first place. Basically, what happens as the solar system is forming is that all the dust out there is swirling, or it starts to swirl as it gets closer to each other and it starts to clump together and it starts to form these masses. And because everything is spinning, it's all spinning in the same direction. Now, it is possible to have a moon or even a planet that is orbiting something in the opposite direction, but usually what this means is that that body formed somewhere else and was captured by the gravity of the thing that it is now orbiting. Generally, the larger moons are orbiting in the same direction, and some of the smaller ones are the ones that are going backwards or retrograde. If you're interested in more than one moon being around your planet, you might want to go with one main one that is more like ours, and then a second one, and this second one would be smaller, farther away, and have this retrograde motion if you wanted it to. If you're wondering how a moon could possibly be captured like this, as it turns out, celestial bodies are not always staying in their orbit. In fact, more recent research has shown that Jupiter has been responsible for all sorts of things happening with planets changing their orbits. And sometimes what happens is a planet or a moon gets flung out of its orbit and out of a solar system, and it could just end up going across empty space for eternity, but sometimes it might end up going into another solar system somewhere, or even another galaxy eventually, and getting caught in another gravitational pull. For those of you who support crowdfunding, I am on the Patreon site and would appreciate any support you can lend. It can be just $1 a month. Higher levels of support get you increasingly cool things, such as PDF transcripts, MP3s of my music, which you hear in these episodes, free ebooks and short stories, bookmarks, and even signed copies of books and CDs of my music. Many of these are unavailable to the public. Your support can help me cover the expenses of producing the show. Even better, you can help me promote it and make it more successful. Without you, there's no point in doing this. Are you benefiting from this free podcast? If so, just go to artofworldbuilding.com and click the big icon for Patreon. And thank you for your support. Let's talk about something I mentioned earlier, tidal locking. If you've ever wondered why the same side of the moon is always facing us, the answer is tidal locking. This means that the moon rotates in the same number of days that it takes to orbit us. When I first heard of this, I thought it was pretty coincidental, and that it's probably rare. Well, the reality is this is what's going to happen to pretty much everything eventually, and the reason is gravity. Despite the huge distances that often separate bodies in space, they have an effect on each other, and that effect is generally one of gravity. Gravity causes objects to either speed up in the case of something that has an elliptical orbit, or to slow down. And that can also happen with an elliptical orbit when it's farther away from the body that it is orbiting. Tidal locking is an eventual result that is caused by this gravity. The moons that are closest to a planet are the first ones that are going to be tidally locked. So if you decide to do this and you've got 3 moons, don't make the first one still be spinning and the second one be tidally locked, because that doesn't make any sense. Actually, there is one potential scenario where that could work, and that would be if the closer moon was recently captured. I can't stress enough that tidal locking is an eventual result. Even our own planet, if given the time, is going to eventually be tidally locked to the sun. It's also possible for both bodies to be tidally locked to each other. For example, in the case of the Earth, it is only the moon that is tidally locked to us. If we were to stand on the moon looking at the Earth, we would still see the Earth spinning, so we would not always see the same side of the Earth. If only one of the 2 bodies is tidally locked, it's always going to be the smaller one. In other words, it's going to be the moon. One really interesting scenario about a moon and a planet that are both tidally locked to each other is that if this was the case and you were standing on the surface of the Earth, for example, the moon would always be in the exact same spot in the sky. It would not be rising and falling like the sunset. It would literally never move. One of the reasons that this is interesting is that half of the planet would see it and the other half wouldn't, and would have no idea that it even existed unless people wrote about it or there was enough technology to get around to the other side of the planet. What if you have a typical fantasy world where the only way to travel is either by dragon or by taking a ship, and you travel around the side of the world, you go across a big ocean, and next thing you know there's this big thing hanging out there in the sky and it's always there. You're probably going to be wondering, what is that? This would have a big effect on the tides as well, because the moon is mostly responsible for tides. And tides are the next subject we're going to discuss. If you'd like to subscribe to this free downloadable podcast, here's how to do it. For iPhone, iPad, and iPod listeners, grab your device and go to the iTunes Store. Then search for The Art of Worldbuilding. From there, download the free podcast app by Apple, and then subscribe to the show from within that app. For Android listeners, you can download the Stitcher Radio app, which is also free, and search for The Art of Worldbuilding. This only needs to be done once, because new episodes will become available in the app each time one is released, and you will never miss an episode. Let's talk about tides. If we want to have a different number of moons than we have here on Earth, we need to understand the moon's effect on the tides. While coastlines and currents have an effect on the tides, by far the moon is the biggest impact, followed by the sun. You may have heard that the moon and the Earth are actually getting farther apart, but this is happening at such a small rate that we're never going to notice. Tides are the reason that this is happening. The basic idea behind tides is that the moon is causing a high tide on the side of the Earth that it faces because it is pulling the ocean away from the planet. And as it turns out, the moon is also pulling the Earth away from the water that's on the opposite side of the planet, which causes a second high tide there. In the Creating Places book and on the website, I have some images that help make this kind of thing clearer. You can just go to artofworldbuilding.com, and on the menu for the second volume, there's a link for images, and then once you get to that page, the images for this particular episode would be under Chapter 2. The quick takeaway here is that the moon causes high tide on opposite sides of the planet, and on the other two sides of the planet, those experience low tide at the same time. This means that there are 2 high tides and 2 low tides every day. The 2 high tides are not going to be the same height, however. For most world builders, this is only really going to matter if you decide to have a moon with an elliptical orbit, because when it's farther away from the planet, the effect on the tides is going to be lower. By contrast, when it's closer, it's going to have more effect. This is just something to be aware of before you decide that your moon has an elliptical orbit and you never give it a second thought. This is a consequence of that. Another issue affecting the height of the tides is that sometimes the moon and the sun are on the same side of the planet, and that is going to cause the highest tides on that side. Another factor affecting the height of the tides is the mass and distance of the moon from the planet. The moon's diameter, or its apparent size in the sky, has nothing to do with it. If we were to change the distance of the moon from the planet or the mass of it, it's going to change the effect it has on the planet. Fortunately, no one's expecting us to tell them the mass of our moons or the distance, and not to mention how those compare to the one we have here on Earth, so we can largely ignore this, but I'm just going to throw it out there as an FYI. Now, one thing that I'm sure you're very curious about is what happens if we add a second moon to a planet. I go into a lot of detail in Chapter 2 of Creating Places, but the short answer is that just like when the moon and the sun are on the same side of the planet, if you have 2 moons and they're on the same side of the planet, they're going to be pulling more on that side and causing a higher tide. Let's next talk about the hours in the day. It may surprise you to know that the moon is partly responsible for us having 24-hour days. Both the moon and the Earth are spinning slower and slower. The reason for this is that their gravity is affecting each other, and in the case of the moon, it is causing the Earth to spin slower, and this is causing the days to get longer. 1 billion years ago, we probably had much shorter days. Why? Well, because we were spinning faster. If you've always wanted there to be another hour in the day, then I suggest coming back in 100 or 200,000 years and you will get your wish. Of course, that doesn't mean you're actually going to live any longer. If we want a scenario where our planet has very short days, then we could decide that there is no moon and therefore this slowing has never taken place. However, the lack of a moon will cause other problems. One of those would be a lack of stronger tides, and then there is the fact that the moon is helping stabilize the tilt of the Earth, and therefore that's affecting the seasons, which we're going to talk about in a minute. Actually, let's do it now. So the moon is stabilizing the Earth's tilt. The Earth is basically leaned over a certain amount, roughly 23.5 degrees. This means that as we rotate around the sun, one pole is facing toward the sun and the other one is facing away. In other words, what this gives us is the seasons. So if you take away the moon, and now the Earth is wobbling chaotically, and there aren't going to be any seasons. Basically, if the moon went away or was destroyed by some sort of asteroid strike, that would be it for the Earth. Maybe not directly, but sooner or later all life on Earth would end up dying because of the moon being gone. Even worse, the moon is helping to stabilize the Earth's orbit around the sun so that we have a roughly circular orbit, and without the moon that would also destabilize and we would end up with an elliptical orbit, which means at times we would be too hot and other times too cold. And the last thing I want to mention about the moon and its effect on the planet is moonlight, of course. If you don't have a moon, you don't have any moonlight. Another issue is that the reason we get moonlight is that our moon is barren. It therefore reflects the sun. If you decide to create a moon that has an atmosphere and a forest and oceans and all that, that is not going to be nearly as reflective. And so therefore, any moonlight that is shining down on the planet is going to be considerably muted. It would probably be a mistake to have a forested moon and then talk about the characters on the planet being out in bright moonlight. If you're enjoying the podcast, please rate and review the show at artofworldbuilding.com/review. Reviews really are critical to encouraging more people to listen to a show they haven't heard of before, and it can also help the show rank better, allowing more people to discover it. Again, that URL is artofworldbuilding.com/review. Let's conclude by talking about some other things that our inhabitants on our planet would see if they look out into the sky, such as stars, constellations, asteroids, comets, and of course, other planets in the solar system. If we're doing fantasy, we may think that we have no need of these, and in fact we may not, but sometimes it can be interesting to add them and help create a sense of a wider world. They don't take that much effort to do either. When it comes to other planets, you should be aware that rocky planets like Mercury, Venus, and Earth, and even Mars, are closer to the Sun, while the gas and ice giants are going to be farther away. Now, when I first did some research on that, that was assumed to be the case, but some of the more recent discoveries by scientists have suggested that something like a gas giant can actually be close to the Sun. I think the jury is still out on whether they form there or not, because there are competing theories about what's going on in the formation of our solar system. But one thing that we do know for sure, at this point as far as the scientists have said, is that planets can migrate and change their place within the solar system. In ours, the big culprit behind this is actually Jupiter, because it has the biggest mass of anything else besides the Sun. There is something known as a hot Jupiter, and what these are giant gas planets just like Jupiter, but they are very close to the Sun, even closer than Mercury. Now, it might sound like I'm giving you some conflicting information, and in a way I am, but that's because of new discoveries have changed things. So what you should do here is just generally follow the advice that rocky planets are closer and that the gas giants and ice giants are farther away, but if you want to mix this up a little bit, you can probably get away with it. Just be aware that depending on what someone else knows in your audience, they may decide that you're wrong, you don't know what you're talking about, but there is some flexibility here. Also be aware that Saturn is not the only planet in our system that has rings. Some of the others have them as well, but they are harder to see, partly because they may be made of darker materials. The ones around Saturn are mostly ice, and that's why we can see them. Earlier I mentioned the idea of a habitable or Goldilocks zone where planets can be and life can flourish on those planets. Again, at last check, scientists have decided that only 2 or 3 planets can exist within that zone if the star is a yellow star like ours. There just isn't room for more than that. Let's talk a little bit about constellations, which is nothing more than a group of stars that suggests an outline of a person or an object. Since things are rotating, the stars and therefore constellations that are visible in the sky change. Here on Earth and in a fantasy setting, we may have assigned supernatural elements to some of these constellations, but this could also happen in science fiction, even if people no longer believe in that sort of thing. And in fact, here on Earth, many of us don't believe in them. Well, we believe in the constellation, but whatever it was supposed to symbolize is something that we don't necessarily ascribe to anymore. One great thing about constellations is that we can just invent this and there doesn't need to be any explanation for it. Something to consider is whether or not a constellation is near the equator or not. If so, then it doesn't matter whether you are in the northern or southern hemisphere, you're going to be able to see it. However, it will appear upside down to you if you're in one versus the other. If the constellation is farther towards one of the poles, like the North Pole, then people in the southern hemisphere are never going to see that. In Creating Places, I go into a little bit more detail about issues that we could have with constellations, such as having a winter god have a constellation that is farther north, but then the other side of the planet can never see that. If you live in the northern hemisphere, then you may be generally unaware of something known as a dark constellation, because most of these appear in the southern hemisphere. A dark constellation is made out of interstellar gas, and it causes a shape in the sky, kind of like when you look up at clouds and see familiar shapes. And the reason we can see this is partly that they are illuminated by stars, and they are also blocking the light of other stars. If you remember from a previous episode on creating gods, sometimes people talk about good gods versus evil gods, and we could use that to some effect here, deciding that the good gods are the ones that have constellations made out of stars, and the evil gods are the ones that have these dark constellations. I want to conclude today with a brief mention of passing asteroids and comets. The difference between them is their composition, with the asteroids not having a whole lot of ice, and therefore they don't have a tail. The comets do have a certain amount of ice, and then they end up with the tail when they come closer to the sun, which heats up and then melts that ice, which forms the tail. Aside from this, we can treat them the same. The only reason we are likely to care about this is if they come close to our planet. One way that you could use this is for it to strike the planet in the context of your story. And the other way is for it to come by at regular intervals, and that this becomes a momentous occasion that people look forward to, and this has often been used for something like prophecies and fantasy. We can use these to create myths, including the Doomsday one. Make sure you tune in for the next episode when we go into a great detail about climates, which is a much more interesting subject than you might think. We're closing out today's show with Blue Sky from my album Some Things Are Better Left Unsaid. Check out artofworldbuilding.com for free templates to help with your world building, and please rate and review the show in iTunes. Thanks for listening.